Firstly, what did the researchers actually do? Well, the best way to learn that is to read the Quanta article. But, if you want the short version, they used a quantum computer to create a quantum entangled state between qubits that has been shown to be mathematically equivalent to a certain kind of wormhole in a 2D spacetime with an anti-de Sitter manifold called ADS2. This duality comes from the famous ADS-CFT correspondence created in the 1990 by Juan Maldacena, one of the most cited pieces of research in all of physics with 18,000 citations and counting. All this comes from two papers. The first is a 1994 paper by Leonard Susskind that suggests that entanglement could be explained by holographic duality between spacetime and entangled particles. The second is a 2013 paper by Maldacena and Susskind that suggests that black holes create wormholes out of Hawking radiation, and these become maximally entangled so as to create wormholes. Originally, this was to address a problem with black holes, the Firewall paradox, but they conjectured it to apply to all entangled particles. Thus, entanglement could be explained as an Einstein-Rosen bridge, example a wormhole. This would satisfy some questions about non-locality in quantum physics, since ER can appear to violate the speed of light without actually doing so. This is called the ER equals EPR conjecture, where EPR stands for Einstein-Podolsky-Rosen, a shorthand for correlations between entangled particles that can be explained by violating locality. The authors of the Nature paper had taken a Sycamore quantum computer from Google and entangled the qubits in it into a particular state that had been shown to be dual to an ADS2 wormhole. This is called the Sachdev-Yekitaev, SYK in short, many-body model. And this model approaches a classical wormhole in the limit of an infinite number of qubits. One of the most interesting aspects of the study was that they used machine learning techniques to simplify the SYK model so that it could work on the Google computer while maintaining the gravitational duality. So, why is it not merely a simulation? A simulation is a way of trying to get answers about what a system would do using computers. A simulation is an important tool in physics for understanding how phenomena behave and can lead to new and testable predictions, but it cannot discover anything that violates the models upon which it is based, since it is simply an expression of those models. While they did use a quantum computer, they did not use it to compute values that would give them answers about wormholes. Is it an analog then? An analog is another way of trying to understand physics where you take a system that behaves like another system and try to extract some properties about that system. So, for example, fluid systems have been used as analogs for black holes, where the speed of sound becomes an analog for the speed of light. The amount of information that one can extract about a system from an analog is much less than a simulation, but it has the advantage that you could see new physics. Whether that new physics in a fluid applies to black holes, however, would be an open question. Analogs are tools for reasoning about other, less accessible systems using small, tabletop experiments. While some have denied it is an analog, I will come back to that. The next possibility is that it is a duality. A duality is where you have two systems that are mathematically, or informationally, equivalent to one another under some assumptions. In other words, you can demonstrate that anything you observe about one system will automatically apply to the other. This is much stronger than an analog or a simulation. If you observe new physics in one system, it must apply to the dual as long as that new physics does not violate the duality itself. So, for example, in a hologram, the information contained in 2 dimensions on the holographic plate is dual to the hologram projected into 3D space. They are dual, but they are not exactly the same. One you can think of as being real, and the other is merely an image. It may seem real, but it cannot contain any information. Hence, while the quantum system is real, the wormhole to which it is dual is a projection, an image. To understand how this works, suppose you had a holographic plate in your hand. Ignore the physical makeup of the plate, that is irrelevant. What is important is the encoded information on the plate. That is what generates the projection. But if you didn't have the material to project it, if the information were simply sitting there, would the projection be real? Our spacetime in which we live may be a holographic projection from a conformal quantum theory, and therefore emergent from it, but that implies that not only is the information there, but there is a mechanism to project that information such that our spacetime emerges. Duality alone is incomplete. There is still physics that has to be described. The mechanism of projection for the ADS-CFT correspondence is via renormalization group flow from low to high energy scales. The length scale, or energy scale itself, is a dimension, but not one that we experience like our ordinary space and time dimensions. You can think of this as the projective dimension for our hologram, the one that is missing that comes out of the plate. We can't probe down nearly far enough to see this dimension very well, but we suspect that we may be living in such a world ourselves. Our universe is de Sitter, not anti-de Sitter, however, and attempts to extend the ADS-CFT correspondence to DS-CFT have led to 25 years of difficulties with no clear success. The wormhole to which the qubit system is dual lives in an anti-de Sitter spacetime with two dimensions, so even if it were projected, it is being projected somewhere other than our own space and time. It is being projected through its own scaling dimension. So is that dimension, and hence the wormhole, real? That depends on your metaphysical leanings. A good analogy to this situation comes from signals, like sound or radio waves. In signals, there is a duality between the time series of a signal, basically what it would look like on an oscilloscope, and its frequency or spectral profile, what it would look like on a spectrum analyzer. Anything that happens in time is reflected exactly in frequency, and they are connected by the Fourier transform, or series. There is a duality between the two. You can even think of the time series as projecting into the frequency series, where a continuous oscillation becomes a series of tones overlapping at different frequencies. Now ask, if a physical field, like an electromagnetic field, lives in space and time, does that mean that the frequency-space dual lives in a real space-time where the dimensions are frequencies? In a way, yes. If we were creatures who lived entirely in frequency space, we might ask the same about space-time. This means that duality is a sort of equivalence between the world that our senses present to us and another world that our senses do not present, but theoretically could present if it made evolutionary sense. We also don't always live only in space and time. Our eyes see colors, not photon oscillations, for example. Likewise, the physics of how our ears work requires that we hear in frequency space, because it would be impossible for our brains to process the oscillations in the time series quickly enough. Some digital technology does exactly this and therefore lives in the space of time series, while our brains live in its projection into frequency space. This seems to make a stronger case for the claims that the news articles are making. They really did make a wormhole. This is where the metaphysics comes in. If you are a Platonist, you may consider the wormhole as living in a kind of allegory of the cave, a mere projection of the real quantum system. Or you could take the Zen view that both are effectively real and both not real, like the sound of the tree falling in the forest. If, on the other hand, you define what is real based on common usage like everybody do, being a pragmatist, then you would object to the way words like wormhole are used because they create faulty impressions. In this way, you sweep the metaphysics away entirely. The word isn't being used the way people commonly use it, and it makes the discovery seem more groundbreaking than it is. Therefore, the problem that comes from calling something you create in a dual world real like a real wormhole is that it isn't one as far as people reading about it are concerned. We don't live in the world where this wormhole exists. We can't study it directly because we live on the holographic plate from which it is projecting. It would be alien noise to us. Whether we are living in a hologram at all is also an open question, so this holographic wormhole may have as much to do with the real thing as a line drawing does. This suggests that, while the connection between the SYK system and a wormhole is a duality, its connection to wormholes in our own spacetime is merely an analog. That was all for today. Thank you so much for watching. See you soon again the next day in the next video. Until then, good night.